Hello everyone. Today's 5 questions. First question is, a ray of light passes through an equilateral prism of refractive index 1.5. We are discussing question number 1 now. We are having equilateral prism means angle of incidence is angle of prism is 60 degree and refractive index is 1.5, such that the angle of incidence is equal to angle of emergence. So I is equal to E and the letter is equal to 3/4 of the angle of prism. So as both of them they are equal, they must be they are equal to 3/4 of angle of prism, that is A. So E and I, both of them, they would be equal to 3/4 of 60. 15 threes of 45 degrees. So here angle of emergence and angle of incidence, they are 45 degree, and what we have to find out here, calculate the angle of deviation. Angle of deviation, we know that is E I plus E minus A. So this is the angle of deviation. So let's find out angle of deviation. In this case, E and I, both of them, they are 45 plus 45. Angle of prism is 60 degree. So it would be 90 minus 60, that is 30 degree. So this is the angle of deviation under the given condition, that is 30 degree. Now question number 2, how does the angle of minimum deviation of a glass prism vary? Question number 2, we need to find out angle of minimum deviation of glass prism. How does it vary if incident violet light is replaced by, here violet light is replaced by with red light. So we have to find out angle of minimum deviation. What would be the effect on angle of minimum deviation? Now we know that refractive index of violet is more than refractive index of red color. So refractive index and angle of minimum deviation, there is a relation. Mu is equal to sine of A plus delta m by 2 over sine of A by 2. Now you see, refractive index of violet is more. So if this term, this is not going to be affected if we are changing the light here, as angle of prism is going to be constant here. So if mu is increasing, then this term would be increasing, means if mu is increasing, delta m would also be increased. So angle of minimum deviation would be increased if we are using violet light, and here violet is being replaced with red. So it means here refractive index is decreasing. So if refractive index is decreasing, so delta m or angle of minimum deviation has to be decreased. So using this explanation, we can say here that mu r, refractive index for red, is less, so angle of deviation would also be less. So delta m will be decreased. Question number 3, how does the angle of minimum deviation of a glass prism of refractive index 1.5 change if it is immersed in a liquid of refractive index 1.3? Okay, we have to again find out the angle of minimum deviation of the glass prisms. Now you see, when this prism is lying in air refractive index is 1, so this would be sine A plus delta m by 2 over sine A by 2. Now you see, when we are placing this prism in the liquid or water, it would become, this particular term is going to be decreased. Now you see here, in denominator we are having 1. Now we are having 1.33. So this term is going to decrease when we are putting the prism in the liquid. So now you see, this whole term is decreasing, so this whole term must be decreased, and as A is constant, so delta m would be decreased. So angle of minimum deviation will be decreased if prism is put in liquid. Next question is question number 4. Question number 4, how does the angle of question number 4, sorry, it is two thin lenses of power minus 2 diopter and 2 diopter. We are having two lenses, powers are minus 2 diopter and 2 diopter. They are placed in contact coaxially. What will be the focal length of the combination? When two lenses are combined, then net power would become P1 plus P2, and if you will take the reciprocal, 1 over F is 1 over F1 plus 1 over F2. So P are written as in terms of focal length. Power is reciprocal of the focal length. Now you see here powers are given, and it is always convenient to add the simple powers instead of adding their focal lengths, because here you have to add the reciprocals of the focal length. So we can add them directly using this formula to find out the resultant power. So power is P1 plus P2. One power is minus 2 diopter, another is 2 diopter. So net power would become 0, and focal length is 1 over P. It would become 1 over 0. That means it would become infinity. So the focal length of the combination would become infinity. Next question, question number 5. It is a convex lens is placed in contact with a plane mirror. We are having a convex lens. It is placed in contact with a plane mirror. So here in contact with the plane mirror, this convex lens is placed like this. A point object at a distance of 20 centimeter on the axis of this combination. We are placing one point object. Let us place it here at a distance of 20 centimeter from the axis of this combination, has its image coinciding with itself. So image is also here. Object and image, they are coinciding with one another. What is the focal length of the lens? Okay, now you see point object is here. Now let us consider two rays from this point object, and now you see after reflection through the plane mirror, the rays must retrace their path so that they should meet here again. And retracing of the path in case of plane mirror would happen only when the rays are falling normally on the plane. So it means rays are falling normally on the plane. So these are the rays which are going to incident on this combination, and using this concept that we have to retrace the paths, and retracing from the plane mirror is possible only when the rays are falling normally on the plane mirror. Now as these rays are falling normally on the plane mirror, so they are going to retrace their path. Now if they are normally falling on the plane, it means both of the rays, they are parallel to the principal axis. Now when these rays are falling back on the lens, then it means a parallel beam of light is falling on the lens, and the parallel beam of light would focus, they would converge at the focus of the lens. So it means this point is the focus of the lens also, and this point is at a distance of 20 centimeter from the axis of this combination. So here what we can conclude, the point focus is also lying at the same point. So focal length of this combination is also 20 centimeter for this particular lens. So focal length is 20 centimeters. So here we have used the concept. Here rays will retrace their paths after reflection through plane mirror. Retracing possible only when rays are falling normally on the mirror. So when they're falling normally, so after reflection, the rays will reflect back normally from plane mirror, means parallel beam will fall on the lens and they will converge at the focus, means object, image and focus lie at the same point. So focal length is also 20 centimeter. So using this concept we can explain. Thank you.